Hello all, my name is Shan Singh and welcome to my YouTube channel. So in this particular session, we will understand what exactly is a life cycle of a data science project. So in general, these are all the 9 steps that we are going to cover in this particular session. See, if you have to build any real world data science project, let's say into some company, you have to follow this life cycle very thoroughly. So let's understand what these 9 steps actually are. The very first is often known as understanding the use case, right? The understanding use case. See, oftentimes it is also known as business understanding. All it means is that at the end of the day, you have to understand what your business is, or what your use case actually is, or what your project actually is. Or you can say what your data is all about. That's what the first step of the life cycle actually is. Okay, so usually what happens is that whenever a client came up with a data science or a machine learning project, right, he goes on a conversation with someone known as a business analyst and a product owner, right? Product owner and a business analyst, and sometimes even data scientist also involves in that conversation. And then all they will do is they will try to actually understand what the problem is, or what exactly is the use case that they have to solve. Now you may ask, who is client, who is product owner, and all these roles. So let's understand what these roles actually are. Let's understand what a client is. So imagine you have a retail shop, right? Let's say you have a retail store. So let's say you want to check how my sales will looks like for the next 4 months, right? So that you can arrange stocks, or you can arrange inventory as per that, right? So I can say that the owner of the retail store is actually a client, because client is someone who is actually facing some problem and they want to solve it at any cost, right? He wants to solve it at any cost. That's exactly the client is. Now let's understand who exactly is a product owner. Product owner is someone, by the way, it is a role in a company. He will actually understand the client request, and he will try to convert the client request into goals and priorities, so that the whole data team or the whole analytics team can actually work on all those goals. Let's say, hey, for this project, very first we will collect the historical data, right? The historical data. As soon as we have the historical data, we will look for the promotional data, or we will look for the holiday sales data, and then we will do a data analysis, right, or exploratory data analysis. Then we will try to build some kind of model which can actually predict the prices for the next 4 months. Once we will build model, then we have to make sure that the accuracy should be at least 90%. So these are actually the deadlines that are being set by the product owner. See, in short, product owner is someone who is responsible to deliver the right product or a solution to a client. That's what the product owner actually did. Let's understand who exactly is a business analyst. So he is someone who talks with a client and product owner, right? Product owner of company, and all he will do is he will actually convert the business needs, right? Business needs into some technical task. With the help of someone known as a data scientist, right? That's what the business analysts do, so that whole data team can actually work on that use case, right? Let's say data analyst, data engineer. So all they will do is they will just try to convert the business problem into a data science use case, right? That's what a business analyst will do at the end of the day. So what happens is that business analyst and data scientist, they basically decide multiple things. So let's understand that. So business analyst along with a data scientist, They basically decide multiple things regarding project. Okay, hey, what about the problem type that we have to solve, whether it's a machine learning or a deep learning or a NLP or a computer vision or a time series use case, right? What about the objective of that use case, right? Let's say here we have to actually predict the sales for next 4 months, right? Similarly, okay, what will be the input columns for this use case? How to evaluate the model that we are going to build? What about the evaluation matrix? Similarly, what will be the cost of the whole project that we are going to implement? See, cost of the whole project, it depends on multiple things like what about the team salaries, what about the software and tools that we are going to use while implementing project, what about the data storages like databases, some files that we have to use, what about the maintenance of the project as well, right? This is something that you have to really take care about that. And what about the source of data, which is one of the most important aspect of the whole conversation. So that's what they will decide in this business understanding. Then let's understand what the data collection actually is, which is the second step, right? So in second step, here comes a data collection, because without data there can't be any data science, right? So what happens is that usually data science team along with a big data team, they will do a simple collaboration and they will try to collect the whole data for the project. They will try to clean that and they will try to store this data for further processing or for further analysis, right? That's what happens in the real world. See, oftentimes what happens is that there is a role known as a data engineer when it comes to data collection, and there is a role known as a big data engineer as well, right? Big data engineer as well. And data engineer usually deals with a medium to large scale data. Let's say Excel data, it could be SQL or a NoSQL database or a CSV file or a JSON file. And a big data engineer is someone who usually deals with a very large scale data. Let's say when data is exactly into some terabytes, or when my data is exactly into petabytes, right? Okay, so let's say my data, if data is in Hadoop or if it is in Spark or if it is in a Hive, that's where we can think of using big data engineer. So once you store this data, see, the whole stuff is actually known as the ETL pipeline. So let's understand what the ETL is. E stands for extraction, T stands for a transformation, and L stands for loading data, right? Loading data. Let's understand what the extraction phase actually is. So moment you extract data, you have the raw data. It means this data can have typos, can have some error, right? It can have some duplicate rows or duplicate columns. It can have some irrelevant rows as well, right? It can have some missing values as well. So that's what actually the raw data is. As soon as you have this raw data, you have to transform this data into acceptable format for the further analysis, and that's what the data transformation or the data cleaning is, right? It is often known as a data transformation. Sometimes it is known as a data wrangling. You may have heard about a data pre-processing, right? And there is one more term known as a data preparation. But believe me, all these terms have similar meaning, right? All these terms are same. Then you have to actually load the data, or you can say you have to actually store that data, store this data so that you can perform further analysis. Okay, so the moment you do a data extraction, right? Okay, coming to the sources of data extraction, you have CSV, you have TSV, you have the JSON, right? See, CSV in short is all about when data inside a file, they are separated using simple comma. That's why they are known as a comma separated values. In TSV, values are actually separated using a tab separator. JSON is all about when you have data in the form of a key value pair. There is a whole area known as a database, right, which is roughly categorized into SQL and into NoSQL. SQL, you can say that data, when your data is exactly in the form of rows and columns, like a simple table. That's why they are known as a table centric database, right? Coming to the NoSQL database, they are often known as a document centric database, right? Because here the data is actually stored in the form of documents. That's what the databases area is. See, then there is a whole area known as a big data platforms where your data can be available at clusters. Okay, so your data can be at a Hive, Hadoop, or a Spark. There can be a lot of platforms. See, you can extract data from Hive using a query language which is HiveQL, which is pretty much similar to SQL, right? Now, the moment you do a data collection, you actually have the raw data. Now, you have to send this raw data for the cleaning purpose by doing a data cleaning. So, all you have is a cleaned data. Then you have to actually store this clean data, or loading this data, or exporting this data, right, or exporting data. And see, when it comes to exporting data, it is often sent to a big data department. Over there, a big data engineer will consider this scenario. So if the clean data you have, right, if it is, see, depends on the size and the volume of data. If the data is quite huge, right, if it is quite huge, let's say into some petabytes, you can think of using some big data platforms just to store this clean data, right? You can think of using platforms like a Hive, a Spark, or some Hadoop, and things like that. But where the data is at the medium size data, right, let's say into some GBs, you can think of storing it into some databases like SQL databases, or can be some NoSQL databases as well. But if the data is a small size data, in such case, you can think of storing these databases into simple CSV or a TSV or a simple Excel files, right? That's how thing works in the real world, and that's how you have to do data collection. Once you do it, then you have to perform exploratory data analysis. Over there, you will say, on top of clean data, as soon as we will apply some analysis, that's what the exploratory data analysis is, right, which will actually give us some kind of patterns, some kind of trends, or some kind of relationships inside data. That's what the EDA, which is a exploratory data analysis, will do. Okay, so imagine you are a data scientist at some big corporate, let's say at Amazon. Let's consider a simple scenario, and imagine you have collected data and cleaned that. Let's say it have features as a product name, order date, quantity ordered, right? What about the region of that customer, the shipping date, and what about the price paid by the customer? Now, let's say you have couple of entries like MacBook, phones, right, iPhones, and the order date is 15th of August, let's say the customer is from Mumbai, and this is the shipping date, and this is the prices, let's say into Indian currencies. These are the following values we have. So imagine this is the whole data. Now, the moment I will ask you, hey, can you analyze this data? Right, that's what the EDA actually is, right? Okay, can you tell me what are the top selling products on Amazon? Or can you tell me what are those customers which actually contribute most to the revenue? Can you tell me that? Or can you tell me, hey, what are those products which were highly profitable? Can you tell me all those products? Similarly, can you tell me how delays in the product, how it actually affect the satisfaction score for the customer? Can you do all these analysis? And that's what the exploratory data analysis is, because you're just trying to explore your data and you can actually use a lot of data visualization tools or packages just to plot the results you have. See, if you are from the programming background, if you are someone who loves Python, or if you are someone who loves R, if you are a Python centric guy, you can use a pandas, you can use a matplotlib package, you can use terrific library like a Seaborn or a Plotly as well just to do that. If you're an R user, you can use some ggplot2, you can use a base R command, you can use a Plotly, you can use some lattice package as well. Now, if you are someone who is from the non-programming background, then comes BI tools. You can use a Tableau, you can actually use a Power BI, right? You can use some ClickSense as well just to do all these stuff. Let's say with respect to the bestseller product, right? Let's say I have done a lot of manipulation and I have came across with this stats like product name and the unit sold. I have the various product as a iPhone, right? The units sold are 90,000. For OnePlus category, the units sold are 60,000, and we have couple of more values, right? And let's say we have somewhere around 500 items. So this data is pretty huge, so it's become extremely hard to make sense out of it. That's why it's a good idea to create plots and charts for this data, right? So imagine I'm going to create this simple chart, let's say a bar chart. So on x-axis, we have the various item names. On y-axis, we have the units sold. And let's say over here we have a couple of bar for every respective item, right? For every respective item, let's say for iPhone, for Mac, for furniture, right? For some grocery. So from this bar you can say iPhone, it is actually the best seller product on Amazon. This is the insight you have. So whatever the analysis you will do, please understand that it's extremely important to make insights out of that, else the analysis you have done, it will be useless. So it's quite important to make insights out of that. Now let's deep dive into the fifth step, which is the feature engineering. Very first, let's understand what exactly the feature engineering is. So on top of features, as soon as we will apply some kind of engineering techniques, right? Engineering techniques, all we have is let's say some set of features, let's say F1, F2 till Fn, in such a way that these features are acceptable for the machine learning, a deep learning, NLP, a computer vision, or a time series use case. It depends, right? So that's what feature engineering actually is. See, let's talk about the various feature engineering techniques you can have. So you can have some feature creation techniques, right? There is a whole area known as a feature reduction, or oftentimes known as a dimensionality reduction. Then comes feature encoding techniques, right? Then comes something known as a feature selection technique. Then there is a whole area known as a feature scaling and normalization, you can say, or feature normalization, right? Okay, let's talk about how you can think of using the feature creation techniques. So imagine you have the hotel booking data, right? Let's say you have the hotel booking data, you have the features as the booking ID of a customer, the arrival date for a customer, right? Arrival date for a customer. What about the customer type? What exactly is the check-in type for that customer? What about the checkout time for the customer? What about the customer location? What about the mode of payment, right? What exactly? And okay, you can have the feature as the whether the customer is satisfied or not. And let's say you have all this data. So hey, can you tell me how we can use some feature creation techniques over here? Can you tell me that? Right? So you have features as customer location, and if you'll use a hotel city feature, you can actually think of creating a new column which can be a is local, which tells you that whether the customer is local or not. Similarly, by using check-in and checkout feature, you can think of creating one new column as a stay duration of that particular customer. So by using feature creation, you are able to create the new columns, and it will actually help the machine learning algorithm just to understand patterns better, and it will actually help the algorithms to improve their accuracy. Now let's talk about the second area of feature engineering known as a feature reduction. Let's talk about that, which is often known as a dimensionality reduction. So on top of data, let's say in data we have 50 or 100 columns. So you can't use all columns, right? Because it will increase the training time, right? You can't use all columns for the algorithm. So can you convert these 50 columns into 5 to 10 new summarized columns? Of course, they should be summarized, right? In such a way that still the 90% of the patterns of data, it is still explainable. That's the whole crux behind the feature reduction, and you can do it using techniques like PCA or a T-SNE just to do a feature reduction. Think of like this: if you have the long review, can you convert this into a very less text but still with the same meaning, right? With the same meaning. That's a whole idea behind what is a feature reduction. Now let's talk about the third area, which is all about a feature encoding. Let's understand. Imagine there is a feature as a customer type which can have the following values as customer may be solo, he may be from the corporate, or there can be a group of customers as well. But there is an issue that my machine learning algorithm will not able to understand all these values, right? Because the algorithms are all about mathematics, and we know that mathematics doesn't work with mathematics works with number, it doesn't work with text or a categorical data, right? These are the categorical data. So that's where feature encoding comes into picture, right? So we will convert the features, or we will encode the features in such a way that we have the number representation of all the features we have, right? You can use techniques like one-hot, frequency encoding, binary encoding. You can use techniques like label encoding. That's what the feature encoding actually is. Similarly, there is something known as a feature selection. Feature selection is all about, at the end of the day, you need important columns just to build some model, right? That's what the feature selection is. So imagine you have the 100 or let's say 200 columns in data frame. You can't consider all the columns because the training time of your model will get increased. So you need some set of important columns, right? And that's where your feature selection algorithm comes into picture. Let's talk about the sixth step, where you have to actually talk about the model building part, right? Or applying algorithms. So all it means is that by applying model, you have to actually do prediction, right? Your algorithm could be a machine learning, it could be a deep learning, it could be a natural language processing, it could be a computer vision, or it could be a time series algorithm. It depends on the use case that you are solving, right? So what happens oftentimes is that first we will take different algorithm. Let's say if you are solving machine learning use case, you can think of considering various algorithms for machine learning, because you never know which algorithm can work best. Then we will give data to all those algorithms, right? And we will try to train that algorithm. Then all we will do is we will try to apply something known as a model selection, right? So what it means is that we will pick algorithms, right? And we will compare that, right? And we will actually compare algorithms. We will compare the performances of the algorithms, you can say, right? Algorithms, and we will try to pick the best algorithm out of that, right? And once you will pick the algorithm, then you have to perform something known as a fine tuning, which is often known as a hyper hyperparameter optimization. That's what the hyperparameter optimization is. See, it's all about you have to just customize the algorithms in such a way that you have the optimized algorithm or you have the optimized model. That's what the hyperparameter optimization is. Now, let's talk about the seventh step, which is exactly a model deployment. What is a model deployment actually is, why there is a need of doing that. So imagine you have built a model M1, then you have to convert into some software so that end users can actually use that. And that software can be some website, it can be a desktop app, or it can be some mobile applications as well, right? That's what the whole model deployment actually is. So now you may ask how to deploy the model that we have built. So very first what we have to do is we have to actually save the trained model we have. We have to actually save the trained model in a binary file, right? Or you can say as a binary file using packages. You can say you can use a pickle, you can use a joblib packages just to store that. Then in the next stage, you have to actually convert it into some APIs, and that's where you can use some Flask, you can use a fast API just to do that. Once you convert it into API, the next thing you have to do is you have to actually host it on some cloud, or you can say on some servers, right? Okay, that's where you can use services like Amazon Web Services or Azure or a Google Cloud platform and tons of things. Then users can actually use those models via website or via some application. That's a whole crux behind the model deployment. Now, see, let's talk about that. So all user will do is, let's say he is going to put some query. Hey, I want the best hotels in Dubai. So this query will get sent to the API, right? That API will actually send this user query to model, right? Then what model will do? Model will actually try to predict what exactly is the best hotel in Dubai, right? And he will return the results in a JSON format, right? Then you can actually think of showing the result, right? You can show result on some websites, you can think of showing on some application. That's how thing actually works in backend. Once you deploy model, the next thing you have to do is you have to actually perform a model testing. Let's understand what exactly it is. So after doing a deployment of your model, you have to perform the model testing, right? A model testing. Most likely you will do a beta testing. So in beta testing, what you will do is you will consider the set of the loyal customers you have, and from this loyal customer, you will actually ask some genuine feedback, right? Genuine feedback. Okay, so as per the feedback, let's say feedback says, okay, the model you have, it is working, it is working good, right? Or it is working accurately, and the model is fine, right? Let's say this is the feedback. Then you can actually make this model available to everyone, right? But what if the feedback says, hey, you have a couple of complaints regarding model, right? Regarding, let's say, accuracy of the model. Then in such case, you have to actually go back. You have to go back to feature engineering stage. You have to fix all the possible issues. You may have to retrain the model, right? And then you may have to test again. That's what whole crux behind model testing is. Once you test the model, the next big thing is that you have to actually optimize the model that you have tested. See, the model optimization is all about the model that you have tested. You have to optimize it Optimize basically means that you have to actually make this model available for the large scale, right? Or you can say for all customers. So before launching it, before optimizing that, you have to consider some steps which are so crucial. The first thing is that you have to make sure you have the backup of your model, right? Because if the new version of your model fails in the production environment, you can quickly switch back to the previous stable version, right? That's why you have to ensure that you have a proper backup of your model. You need the backup of your data as well. So the moment you clean data, right, the moment you clean data, you can think of having a backup into some data lakes or into some warehouses, right, into some warehouses, so that when you have to retrain your model again, you can actually look for data into data lakes or into warehouses. The third important thing is you have to use something known as load balancers or load balancing. See, let's say millions or billions of users are using the model you have built. Let's say you have built for Make My Trip for hotel booking industry. You have built, let's say, this model. So you can think of using some load balancers, like you can use some Kubernetes services, right? You can use, let's say, AWS. You can use some Kubernetes services, which will actually spread the whole. All they will do is they will spread the user request they have into multiple servers, right? That's what the load balancers will do. The next thing is you have to perform something known as a model retraining, right? A model retraining. In model retraining, all you have to do is, see, usually data evolves. So when data evolves, patterns inside data also changes, right? When pattern changes, you have to retrain your model, right? You have to retrain your model, else the older model you have, it starts performing bad. It starts performing bad. That's why you have to do model retraining. So that's all about the life cycle of a data science project that you really need to know in order to solve any real world data science project. So that's all about this whole session. For those of you who have any doubt, please do let us know via comment section of it. Thank you, take care, and God bless you.